Hey everybody, I hope you're doing well. In this related rates video, I want to talk about two cars traveling away from each other. One is going to be going east and the other one is going to be north. So the specifics of the problem. Car A is going to be traveling 15 kilometers east. Car B is going to be traveling at 25 kilometers an hour going north. And they're going to start at different places. So my goal here is to figure out how fast are these cars traveling away from each other 2 hours into the trip. So here's the idea of a picture. Car A is going to be traveling east. Car B is going to be traveling north. My goal is to figure out how fast these cars are traveling away from each other. In other words, the distance. How fast is the hypotenuse changing in this problem? So since A is moving to the right, east, I'm going to label this distance with an X. The distance from B, or for B, I'm going to label with a Y. The distance between the two cars, I'll label it with a Z. You can label this anything you want. So what do we know in this problem? Well, do we know how fast car A is moving? Well, yeah. We know that A is moving at 15 kilometers an hour. What about car B? Well, reading it again very quickly, says 25. Now, what do we want? Well, symbolically, what we want? We want dz dt at time of 2 hours. So where are these cars 2 hours into the trip? Well, X and Y, car A and car B. Car A travels 30 kilometers because it's 15 times 2. But, quickly reading this again, I have to put an extra 10 kilometers on there because that's what the problem is telling me to do. What about car B? Well, I'll write out a little bit more of this one. It's going to be 50 plus an extra 20. So I get a 40 for this. 50 plus 20 is 70. So I'm probably going to need those two numbers in my calculations. So what about my model? How do I relate all these things in here? Well, my model. First thing I always think about is the Pythagorean theorem. And I need to relate dx dt, dy dt, and dz dt together. Well, this is a prime candidate for that. So I'm going to take a derivative of this model. Using the chain rule, I get 2x dx dt plus 2y dy dt. That's using the chain rule twice, and the sum rule in there is equal to 2z dz dt. So what pieces of information do we already have? Well, I know dx dt. I know what x is, so that's good. I know what dy dt is, and I know what y is. Our goal is to figure out dz dt. If we could figure out z, we'd be in good shape. Well, if I know x and I know y, well, we know how this relates. So really quickly, I know that z is equal to 40 squared plus 70 squared. So I do know this. I do know this. Right there. And now, I just have to plug stuff in. So let's try that. 2 times 40 times 15 plus 2 times 70 times 25 is equal to 2, well, 40 squared plus 70 squared, square root of that looks like, I think, 10 times root 65 times dz dt. Now, one thing I can do, I see a 2 in every single one of these. So right now, we're sitting at an algebra step. And I'm just going to put everything together. 40 times 15 plus 70 times 25, all divided by 10 root 65. And that is dz dt. You can do the numerical calculations on your own on this one. But again, like all the problems, what are the units? I know that distance in this problem is measured in kilometers and time is measured in hours. So the units for this is kilometers per hour. I hope you found this video useful. If you have any questions, let me know and have a great day. Bye.